Very impressive. Yesterday was Pythagorean theorem. The distance formula is the Pythagorean theorem. It's the same thing. It just looks like this. Distance is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So I'm going to show you how this becomes the Pythagorean theorem. First, we're going to find the distance between point A and point B. First, I have to identify the coordinates. What's the coordinate of A? -2, -3. And what is the coordinate of B? 2, 2. So when I go ahead and I use the distance formula, thank you for saying that. Right. So let's take Jack's point, which is, say you have 16 plus 9. Those are both perfect squares, correct? So can't we just say that that's the same thing as, so you can cancel, get 4 plus 3 is 7? But yet, if you combine them, you get the square root of 25, which is 5. So those are not the same. So the reason why that doesn't work, Jack, is because of this. If I have, say I have 2 plus 5, and you want to square that, you can't just distribute the 2 to each of those and square the 2 to get 4, and square the 5 to get 25, right? That doesn't work, does it? So same thing in this situation. You got to be careful with that. So that's the formula. So the distance is equal to the square root of, what is x sub 2? What's my second x value? 2. Minus, what's my first x value? -2. Squared plus, what's y sub 2? 2 minus the first y sub value is -3, and I square that. So the distance is equal to the square root of 2 minus -2, 4. And 2 minus -3, 5. So before we simplify that, I want to show you why we're doing the Pythagorean theorem right now. Look at these 2 points. I can make a right triangle between the 2 points. What's the distance of that leg of the right triangle? How long is it? 4. Notice where the 4 came from? What is that leg right there? 5. As you can see, I've got the 5 right here. And when you come up with the hypotenuse, you end up having to square root it, correct? Which is your square root piece. So you're just doing the Pythagorean theorem. That's all the distance formula is. So distance is equal to the square root of 16 plus 25, or the square root of 41, which you may not simplify. When we look at 2 points, we also like to identify the middle, or the midpoint. Okay? So if I look at these 2 points, I want to find the midpoint between them. You might estimate it's about right here, somewhere around there. We're going to look at the formula. If I ask you what's the middle of 10 and 6, what would you tell me? How'd you come up with that? You take 10 plus 6 and you divide it by 2. So you add them together, you divide by 2. So the midpoint is x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. The midpoint is a coordinate. It is a coordinate. What do you get if you add your x values? 0 over 2. What do you get if you add your y values? -1. So your coordinate is 0, -1/2. That's the midpoint. That's the middle of that segment. Now my drawing doesn't show it very well because I didn't draw my line very straight. But that's okay. Any questions on what we've shown so far? there was somebody who sat up here during second hour, and they said to me, they said, Mr. Gentz, they said, this is so much easier than when I learned it in my ninth grade or 10th grade year. Why is that? And there's two reasons. Number one, it's always easier the second time you've seen something. But number two, generally, the older you get, the more mature you get, and the better learner you are. It's kind of how it goes. Folks, last test, you were simplifying rational expressions and radicals. If I tell that to any math teacher, they say, wow, there's some students who could struggle with that. But if I say we're going to do the Pythagorean theorem and the midpoint formula, they say, hey, when the students get those on the test, they should be able to get those. Okay? That's supposed to be, hopefully, a little bit easier content. So let's make sure we can get them. Let's look at these questions. I'm going to do one, you're going to do one, I'm going to do one, you're going to do one. It says find the distance and midpoint between the following points. You see this type of question on the ACT or on a test, the fact is you don't have to use the distance formula. You could just use a Pythagorean theorem. Make a triangle out of it. What's the length of this side? What's the length of this side? What's the length of this side? 6. So if I want to find the hypotenuse, I simply do 4 squared plus 6 squared is c squared. 4 squared is 16. 6 squared is 36. It's equal to c squared. What is 16 and 36? 52 is equal to c squared. I root both sides. What's a perfect square that divides evenly into 52? Starts with F, rhymes with or. 4. You got the root of 4 times the root of 13, or 2 roots of 13. So with this problem, it says find the distance and the midpoint. We just found the distance. Now I'm going to find the midpoint. You've really got to think about the coordinate. What is this coordinate right here? -3, 3. What is this coordinate right here? 3, -1. So if you want to find the midpoint, you add the x's and divide by 2. Add the y's, divide by 2. If I add the x's, what do you get? 0 divided by 2 is 0. Now let's add the y's. 3 and -1 divided by 2. Does it look like 0, 1 is my midpoint? It does. You do the next one on your own. Do number 6, just like I did it. I got the root of 73. 73 is a prime number. Nothing divides into it. That's a perfect square. For the second one, I had -1, -3, and 2, 5. 2 plus -1 is 1 divided by 2. I get 1/2. 5 plus -3 is 2 divided by 1 is 1. We all good? What's different about the next two examples? There's no graph. So we're just going to use, a straight up formula here. Distance is square root of x sub 2 -1 minus 3 quantity squared plus -3 minus -2 quantity squared. Jack, see why the squareds can't go away? -1 minus 3, -4, squared is 16. Folks, this is what drives me nuts, is when you do this and you don't put -16, what do you put? You put -16, okay? When you square something, it becomes positive. So that's an easy way to get a problem wrong, is to throw a negative on there. You square something, it's going to be positive. Plus, -3 minus -2, I got to add the opposite. Squared. So it looks like the distance is the square root of 17. Piece of cake, upside down. 45. 1 through 80, odds and evens, and every other. Midpoint. If you want to find the midpoint, you need to add the x values, which gives you Divide by 2 and you get 1. -2 plus -3 divided by 2, we just got -5 halves. Again, these are problems I want everybody to be able to get. Go ahead, do number 8 on your own. I'll hand out the assignment. Really, everybody should be able to get the assignment done in class. It's just the front page. There's like 7 problems. Okay, let's check, see how you did here. Square root of 4 minus 2 squared plus 4 minus -7 squared. So you should get 4 minus 2 is 2, squared is 4, and 4 minus -7 is 11, squared is 121. Square root of 125. Can you simplify the square root of 125? 25 goes in how many times? 5. 50 bill. We get 5 roots of 5. Now I'm going to do the midpoint. What do you give you? Add the x values. Add the x values. 6 divided by 2 is 3. Now I'm going to add the y values. -7 and 4 makes -3 over 2. Piece of cake, upside down. So I gave to you the worksheet. The answer key is already posted. Please check your answers. Please make sure that your homework is done the day before the test, ready to hand in immediately so you can work on that study guide and we can have awesome, awesome tests this time around. This is a test that you can do well on. Ran it off just for you.